Today we're going to go through trigonometric ratios and how to use them to calculate an unknown side length for a right angle triangle. Now these can only be applied if the triangle has a right angle in it, otherwise this is completely useless. So important to note that when you have a right angle triangle, the side that's opposite the 90 degrees is always, no matter what, going to be called the hypotenuse. Now the words adjacent and opposite depends on the angle in question. So right here I've put an angle down. This angle is just called theta, and because the angle's here, the side that's opposite to the angle is called the opposite, and the side that's next to the angle is called adjacent. So adjacent actually means next to. Now the moment I scrub that out and I put an angle there, then this adjacent will become opposite, and that opposite will become adjacent. The only thing that's static, that never changes, is the location of the hypotenuse. Okay, but opposite and adjacent really depends on where the angle is labeled, and they're named in relation to that angle. So the three ratios that you would know from previous would be SOHCAHTOA, S-O-H, C-A-H, and T-O-A. SOHCAHTOA is a way we can remember the three ratios. The symbol theta here represents an angle, and we can use this to find the length of an unknown side when an angle and one of the sides are known. So I'm going to take you through using these three ratios to solve this question and this next one down here. So I've just redrawn the example down here, and let's have a look and see which trig ratio we need to apply. So the first thing you're going to do is you're going to establish what you've got. So I know in this example I've got x here, which is what I need to find, and I know that the x, because it's opposite the right angle, it's going to have to be the hypotenuse. Okay, so this is the hypotenuse here, and I've been given an angle, and therefore this side, which I have a value for, is going to be called the opposite. So I've got hypotenuse and opposite. There's no point naming this one because it's not going to help us. So I've got hypotenuse and opposite, and if you scan your eyes through the three ratios, the only ratio that actually has opposite and hypotenuse is this one here. So that's the one that you're going to use for this example. So you're going to pluck out sine, and theta represents the angle. So you're representing, you're going to write the angle instead of theta. So sine 64 degrees is equal to opposite, which is 9, over hypotenuse, which is our unknown. And then all you basically do is, if the unknown is the denominator, you can basically switch places with sine 64. So x is equal to 9 over sine 64, and all you simply do is type that into the calculator and you'll get your answer. So 9 over sine 64 gives us a value of 10.01. So x is equal to 10.01, and we don't have a unit, but that represents the length of this side here, the unknown side. Okay. Now that swapping thing that we do can only work if the unknown's on the bottom. If it's on top, then you simply just multiply the other side by the denominator, but I'll get to that in the next example. So down here we have another example, and first what we're going to establish is, what do we actually have here? Now this being the right angle means that that's the hypotenuse, so we don't have that. We've got an angle here, and this is going to therefore be called the opposite, and next to it is going to be called the adjacent. Okay, and the only ratio that we have that includes opposite and adjacent is the tan ratio, that one up here. Tan theta is equal to opposite over adjacent, and that's exactly what we write. Tan, instead of theta we write the angle of 31 degrees, is equal to opposite, which is x, over adjacent, which is 400, and now all we do is solve for x. So to solve it, you just multiply both sides by 400, or you move the 400 over to the other side and multiply. So x is equal to 400 times tan 31, and you basically just type it into the calculator. So 400 times tan 31 degrees, 240.34. So x is equal to 240.34, and whatever units it's going to be. If it's in meters, this would be in meters as well. So the unknown length, this one here, is that. And that's all it is. So the most important thing is establishing or choosing the correct ratio to use. And you do that by establishing what you actually have.